When we send a message today, we are casting a digital bottle into a vast, turbulent ocean. Your text, your video call, your email, it all gets broken down into tiny packets of information. These packets travel through a sprawling network of cables, routers, and cell towers. They journey across cities, under oceans, and even bounce off satellites orbiting our planet. For this intricate dance to work, every single link in the chain must be intact and functioning. But what happens when that chain breaks? What happens when the very infrastructure we depend on is the first casualty in a crisis? It's a question we face with terrifying regularity. Think about a massive earthquake that has just ripped through a city, or a wildfire raging across a remote landscape. Power lines are down. Cell towers are twisted, smouldering ruins. The very internet and wireless signals we take for granted have vanished into thin air. In these moments, first responders are flying blind. They need to know where people are trapped, how the fire is spreading, or where to safely land a helicopter. But their radios crackle with static, and their devices show no signal. This communication blackout is more than an inconvenience. It is a life-threatening void where critical information is lost, and precious minutes tick away without coordinated action. This is the fundamental weakness of our modern communication systems. We have built a magnificent global web of connectivity, but it is a web that can be easily torn. For a message to get from point A to point B, it must physically travel through a series of intermediaries. Every one of these points is a potential failure. Even more troubling, every one of these points is a potential vulnerability. A clever hacker doesn't need to break into your phone. They just need to find the weakest link in that long chain of data transmission, intercepting information, or worse, injecting false data to create chaos when clarity is needed most. So, the challenge is immense. How do we create a way for our helpers, our robotic eyes in the sky, to talk to each other when the world around them has fallen silent? How can they share what they see and coordinate their efforts in a way that is instantaneous, unbreakable, and completely secure from prying eyes? The answer doesn't come from building a better radio or a stronger cell tower. The answer comes from a place far stranger and more wonderful. It comes from harnessing a fundamental, almost magical, property of the universe itself. We have to look to the quantum realm. To understand the future of communication, we have to journey into the weird and wonderful world of quantum physics. Imagine you have two special coins. These aren't just any coins. They are entangled. This means they are linked in a profound way. You give one coin to your friend and keep the other. Your friend then travels to the other side of the planet, or even to the moon. Now you flip your coin and it lands on heads. The instant you see its heads, you know with absolute certainty that your friend's coin has just landed on tails. There's no signal sent, no message transmitted. It just happens, instantly. This is the essence of quantum entanglement. Albert Einstein famously called it spooky action at a distance because it seemed to defy our classical understanding of the universe. It's a cosmic connection where two particles, like photons of light, become linked as one unified system. No matter how far apart you pull them, their fates remain intertwined. A measurement of one particle's property, like its spin or polarization, instantaneously influences the corresponding property of its partner. It's as if they are two sides of a single, invisible coin, separated by vast distances, but still part of the same whole. They are having a private conversation that bypasses space and time as we know it. For decades, this was a fascinating but purely theoretical idea, something physicists debated with chalk on blackboards. But we have moved beyond the blackboard. Scientists have not only proven that this spooky connection is real, but they are now learning how to control it and use it. In experiments conducted everywhere from university labs to the International Space Station, we have confirmed that entanglement holds true over incredible distances. We are no longer just observers of this quantum magic. We are becoming its conductors, learning to orchestrate this silent, instantaneous symphony that plays out across the cosmos. This isn't about sending information faster than light, which the laws of physics forbid. You can't use an entangled pair to just shout hello across the galaxy. Instead, it's about establishing a shared secret, a pre-arranged codebook written into the fabric of reality itself. By manipulating one particle and observing the effect on its partner, we can transmit information without sending a single bit through the open air. This shared state allows for a new kind of communication, one that is not broadcast, but rather revealed, creating a channel that is fundamentally private and unhackable, because there is literally nothing in between to intercept. Now, let's bring this cosmic spookiness back down to Earth and place it in the heart of a disaster zone. Imagine a swarm of drones flying over the chaotic aftermath of an earthquake. The ground is a maze of collapsed buildings and impassable roads. There is no Wi-Fi, no cellular service. In the past, each drone would be a lone operator, sending its video feed back to a central command, creating a bottleneck of information. But now, these drones are different. They are equipped with a groundbreaking new framework, a system like the one developed at Virginia Tech called eQMARL, which stands for Entangled Quantum Multi-Agent Reinforcement Learning. It's a mouthful, but what it does is revolutionary. Each drone in this swarm carries a set of quantum bits, or qubits, that are entangled with qubits on other drones. They are all part of that same spooky, interconnected system. When one drone flies over a collapsed apartment building and its sensors detect the faint sound of a survivor, it doesn't need to package that audio data and try to broadcast it over a non-existent network. Instead, it encodes this vital information onto its qubits. Because of entanglement, the state of its qubits instantly influences the state of the qubits on every other drone in the swarm. It's not a message sent, it's a shared reality that updates for all of them at once. This quantum conversation allows the drones to collaborate in ways that were previously science fiction. The entire swarm feels the discovery simultaneously. One drone might adjust its flight path to get a better visual with a high-resolution camera. Another, carrying medical supplies, can immediately calculate the safest route to the location. A third might begin mapping a clear landing zone for rescue helicopters. They aren't just following individual orders. They are operating as a single cohesive intelligence, learning from each other's discoveries in real time. This is what the researchers demonstrated, a massive improvement in teamwork and efficiency compared to drones that communicate classically. The benefits are staggering. First, there's speed. The information is shared instantly, not at the speed of radio waves, but at the speed of quantum correlation. In a rescue operation, this shaves off minutes that can mean the difference between life and death. Second, there's security. Since no data is traveling through the open air, there is nothing for a malicious actor to jam or intercept. The communication channel is embedded in the quantum state of the particles themselves. It is, by its very nature, a closed and private network, making it perfect for sensitive missions where information integrity is paramount. This is a level of security that today's encryption methods can only dream of. When we compare this new quantum method to how devices connect today, the difference is as stark as night and day. Our current internet is like a complex system of roads and highways. For information to get from one city to another, it must travel along these public routes, subject to traffic jams, roadblocks, and potential ambushes. Quantum entanglement, on the other hand, is like having a personal, instantaneous teleporter. There is no journey, there is only arrival. It sidesteps the entire vulnerable infrastructure, creating a direct point-to-point connection that is immune to the chaos of the physical world. This is what makes quantum technology so special. It doesn't just improve our current systems, It offers a completely new paradigm. The real-world applications are as vast as our imagination. In the fight against wildfires, an entangled drone swarm could map the fire's edge with unparalleled precision, sharing data on wind shifts and hotspots instantly so that firefighters on the ground can react before the blaze overtakes them. After a hurricane, drones could collectively build a complete, real-time map of the damage, identifying which neighborhoods are flooded and which roads are clear, all while the storm still rages and conventional communication is impossible. This isn't just an incremental improvement, it's a quantum leap in our ability to respond to crises and keep people safe. While full-scale deployment may still be some years away, progress is accelerating at a breathtaking pace. Breakthroughs in synchronizing quantum clocks on mobile platforms and shrinking the necessary hardware are rapidly closing the gap between the laboratory and the field. What was once confined to room-sized experiments is becoming compact and mobile, paving the way for practical, life-saving applications. We are standing at the dawn of a new technological era, one where the deepest and most mysterious laws of the universe are being harnessed to solve some of humanity's most pressing challenges. Looking forward, this technology will extend far beyond disaster relief. Imagine secure global financial transactions, unhackable military networks, or even new forms of artificial intelligence that can learn and collaborate in ways we can barely comprehend. We are learning to speak a new language, the language of the cosmos itself. By mastering this spooky action at a distance, we are not just building better gadgets. We are forging a deeper, more resilient, and more intelligent connection with our world and with each other, ensuring that even when everything else fails, the lines of communication and hope remain open. The universe has given us a strange and powerful tool, and we are finally learning how to use it. If you found this fascinating, like the video, comment with your thoughts, and share it to